Scooby-Doo, looking for you. Scooby-Scooby-Doo, where are you? All the stars are here, waiting for you. Couldn't have a show without you.
For the next several videos, I want to spend some time talking about linear functions. A linear function is a function that has a graph of a straight line. All linear functions may be written in the form of f of x equals mx plus b. Now you may be more familiar with y equals mx plus b. It is the same thing because remember, if you can solve for y, you can isolate y to the first power and only get one result, which this is only one result. You have a function, and if you have a function, you can rename it something like f of x or g of x using what we call function notation. So the m is the slope. Now, what is the slope? We'll spend a good bit of time talking about what slope is. Slope measures incline. We'll mention that in a minute. And b is the y value of the y-intercept. And so if I draw you just an example of a linear function, so a function that, again, is a straight line, I could call this f of x, all right? Then this point is 0, b. So this would be your b right here. Whatever that value is, whether it be 2, 3, 4, 100 up here, that's what would go here. And then the m is this incline. Now, it turns out that the higher the m, okay, the steeper the incline, so this would have not a huge number for your m. And we'll talk more of that as we go through. Okay, so again, all of these are straight lines. Now, how do you recognize a straight line before I flip to the next screen? You know that you have a y to the first power and an x to the first power. I said that backwards, but both have an exponent of 1. There are no square roots or radicals in your problem, no absolute values in your problem. So this is just what we call a polynomial that has exponents for y and x of 1. And of course, anytime you can name a function, f of x, g of x, h of x, then that is y to the first. So it's x to the first that'll give you a linear function. What I have for you here is a description of slope. Most of you have heard the term before that slope is rise over run, but what does that really mean? Okay, so I've just got a random straight line drawn here for you that does have an incline to it. Now, rise is how far you go up from one point to another. Now, if I just run across this line, notice we're both going up and to the right. So if you look specifically just how far up or down, depending on the line, but in this case, how far up to get us to the next point, that's your rise. And then how far over to get us to the next point is your run. And it was decided way back that rise should be in the numerator. You go up first, and run should be in the denominator. When rise is a positive number, you go up. If rise were a negative number, you would just go down. If run is a positive number, you go to the right. If run were a negative number, you would go to the left. Okay, and then finally, how do we calculate rise? Well, rise is up and down, right? Well, what measures up and down is your y value. So if we took it, if you look at your y1 and your y2, and let me undo that, y'all. I thought I was being good by using a highlighter. That wasn't a highlighter at all. Let's try this again. So your y1 and your y2. The distance between those two is just y2 minus y1. Okay, and then on the other hand, when you're looking at run, that's x values along this way. So x1 and x2, and the distance between those gives you x2 minus x1. So real simple formula, you subtract the y's in the numerator, you subtract the x's in the denominator. So next, let's try some of those. All right, here we go. Let's try some of these problems. It says calculate the slope of each line. containing the following points. Then I want to graph the line. Now, I didn't have a whole lot of room to put my graphs. I know these are the tiniest graphs you've ever seen in your life. I'm probably going to have a hard time graphing on them, but we'll see what we can get away with. But when I do this, here's what I want you to notice. We've got 2 points. You can name either one x1, y1, x2, y2. So I'm going to call this guy x1, y1, and I'm going to call this guy x2, y2. So again, what I want you to realize is if you wanted, this could be x2, y2, and this could be x1, y1. That doesn't matter. Here's what I don't want you to do. You can't call this x1 and this y2. Okay, the 1's go together and the 2's go together. So if I use my formula, m is equal to y2, which is 7. So right here, minus y1, which is 2. That goes in my numerator. And then on the other hand, I subtract x's in the bottom. Now again, if I start with 7, I have to start with 5 in the denominator. So that's 5 minus 3. I continue to simplify. 7 minus 2 is 5. 5 minus 3 is 2. And this is my slope. Okay, and let's take another minute and plot these points. So I've got 3, 2. Again, I'm going to do the best I can here. Probably need glasses. And then 5, 7. Okay, and then I could connect those dots to create the line. I could continue on. This line really does continue on. Okay, but that's what we're looking at right there for that one. Now, I'm going to revisit all the graphs when I finish this explanation, but let's practice again. Let's find slope. Now, you want to get in the habit of naming these things. So, again, x1, y1, x2, y2. So, if I calculate slope, that's called m. I do y2 minus y1, so that's negative 10. Careful with your signs, that's minus a negative 4. So why are there 2 minuses right here? This is subtraction, which is directly from the formula. This is the sign of the 4. It's negative, so you have to have both of those. In the denominator, it's going to be positive 2 for my x2 minus, here we go again with this double negative, a negative 1. Now what happens when you have 2 negatives, you know that turns positive. So this is negative 10 plus 4, which is negative 6, divided by 2 plus 1, which is 3. Negative 6 divided by a positive 3 is a negative 2. So I have a slope of negative 2. Now I want to graph or plot these points. Negative 1, negative 4 is here. And then 2, negative 10 is here. I connect these points to create a straight line, and I have a line that's not really that squiggly, but that makes the point that I'm going to make in just a minute. For extra practice, we're going to do this 2 more times. Now, honestly, I have a plan over here to the right with all these graphs, and it doesn't hurt to practice this over and over and over again. So x1, y1, x2, y2. Here we go. Negative 3 minus a negative 3. Again, y2 negatives, 1 subtraction that comes directly from the formula. 1 is the sign of this negative. In the denominator, since I started with the second y or y2, I have to start with this second x. So 6 minus 4. Negative 3 minus a negative 3. These two turn to plus. Negative 3 plus 3 is 0. 6 minus 4 is 2. 0 divided by 2 is 0. Now if I plot these points, I've got 4, negative 3, and I have 6, negative 3. Well, what that does is that gives us a horizontal line right through y equals negative 3. Okay? And then the last example, let's use blue. Alright, so I have x1, y1, x2, y2. So m is equal to, I don't like that equals where it doesn't belong. So m is equal to y2, which is 7, minus y1, which is 2, divided by x2, which is negative 2, divided by x1, which is negative of a negative 2. Gives me 7 minus 2 is 5, divided by negative 2 plus 2 is 0. Now that ought to make you think twice. You cannot divide by 0. So that doesn't mean this doesn't have an answer or it doesn't have a slope. It has an undefined slope. Okay? And when I graph this, I'm trying to graph negative 2, 2, gives me that point. And I'm trying to graph negative 2, 7, which gives me that point. And I connect the dots, and that gives me a vertical line at x equals negative 2. Now, the point I'm trying to get you to get from this, by doing 4 different examples, you really only needed to see one to actually do the calculations, but I want you to compare the answers. So notice 5/2, that's a positive number, right? It's a positive number. Positive numbers have, notice this line in blue is increasing from the left to the right. So that graph is rising, or you could say it's increasing, okay? One or the other is fine. Increasing is really better to me, okay? Notice you have, in the red, you have a negative slope, and lines with negative slope are decreasing. Now, this graph is falling from left to right, so it is decreasing. A zero slope, I tend to think about this like a hike. A hike with 0 incline would be the easiest hike that you could do. And notice this hike has 0 incline. There is no incline at all, so that's a horizontal line. And again, if you think about it, a hike, it's going to make pretty good sense, okay? And then the last graph, which is blue, all right, we got an undefined slope. Well, again, if you think about this as a hike, you can't hike vertically. Okay, you could climb, but that's not what we're talking about. You cannot hike vertically. So that's an undefined slope. And a lot of people get the 0 and undefined slope mixed up. Okay, we'll make sure you're comfortable with that. So an undefined slope has a vertical line. And basically that's an impossible hike. So now we have another type of problem. They want us to write the equation of the line that has a given slope and passes through a given point. Now anytime you see this expression, write the equation of a line, automatically, here's what I want you to think. I need to use y equals mx plus b. Okay, so right off the bat, before you even read the rest of it, write the equation of a line, then you got y equals mx plus b. Now to use this formula, you're required to plug in m and plug in b. That's your goal every time. What's going to vary is the information that's given. In this case, we have m. So now I could write it as y equals negative 3/2 x plus b. So we're a step closer. I plugged in for m. I still have to find b. We weren't given b. It doesn't tell us that the y-intercept is some particular value. They just gave us a point. Now what we use the point for is this is x and this is y. Okay, so that is an ordered pair, and that's what I'm going to do. I'm going to plug in y is 1 equals, and then I still have my negative 3/2, and then x is negative 2, and then I've got plus b. Okay, so I used my point, my xy value, to plug in for y and x. Now once everything is substituted in and the only variable you have remaining is b, you can do the math to solve for b. Alright, so that's what I want to do now. Now notice I'm multiplying fractions together. That negative 2 is really over 1. When you multiply fractions, what you can do beforehand is you can cancel numerators and denominators that have common factors. So those 2's cancel. Now if they're both in the numerator or both in the denominator, we couldn't. But one in the numerator, one in the denominator, they cancel. That leaves me with a negative 3 times this negative, which still exists, which makes that a positive 3. So now I have 1 equals 3. That's really 3 over 1, right? Because that 1's still there. But it's not required to do the math. So 1 equals 3 plus b. Now I'm going to do the algebra to isolate b. Okay, so now b is by itself on the right-hand side of the equation, and 1 subtract 3 is negative 2 on the left. So now we have a b value. So now I go back to my y equals mx plus b, and my final result will be y equals, remember in aqua here, you've got to substitute m, that's negative 3/2. And then once again in the aqua highlighted, you got to substitute b, which is, I wrote my addition sign way too soon. It's a negative 2, so I put minus 2. So this line, if you were to graph it, I promise you, it has a slope of -3/2, and it passes through the point -2, 1. All right, so check this out. Write the equation of a line. Okay, folks, here we go again, right? Anytime it says write the equation of a line, we know what we have to do. We have to write y equals mx plus b. So there we go, y equals mx plus b. I'm going to need to substitute for m and substitute for b. That is required every single time you do one of these. Now, when you read the rest of your problem, it says that passes through the points -3, -2, and -2 and 4. Notice we don't have an M and we don't have a B. So like our last problem, we don't have a B, but now we have a brand new issue. We don't have an M either. Now, we can find M. We practiced that quite a bit 2 slides ago, okay? So if this is X1 and this is Y1, and this is X2 and this is Y2, we know how to find M. Remember, it's Y2 minus Y1 over X2 minus X1. So that's the very first step. So that's 4 for Y2 minus a -2 for my Y1 divided by -2, this -2 for my X2 minus -3 for X1. I continue simplifying. I'm going to go to the right this time. These two negatives turn positive, so it gives me 6. These two negatives turn positive, so I have a -2 and a +3, which gives me 1, which overall 6 divided by 1 is 6. So I have an M. So now we're at the point y equals 6x plus b. Now remember, the next step was to substitute for x and y. Okay, so I need to substitute something for y and something for x. Well, I can do that. Okay, which point do you want to use? Well, it doesn't matter. You can use -3 and -2 for your x and y, or you can use -2 and 4 for your x and y. It honestly doesn't matter. I think I'm going to use the -2 and the 4 only because the 4 is positive. So working with positive numbers is usually a little bit easier. So that's why I'm doing that. So I have 4, and then in red equals 6. And then back in blue, we're plugging in -2, and then plus b. So again, all I did was plug in an x and a y. Either set of points will work. And now I have 4 equals 6 times -2, we know is -12, plus b. I add 12 to both sides of my equation. All right, so 4 plus 12 is 16 equals b. So now I have b. The last step is y equals, now I'm going back up to my highlighted original equation. M was 6, x, and then b was 16. It's positive, so I put plus 16. Here we are again. Write the equation of the line that passes through the points 3, 0, and -1, 2. So I want you to get in the habit of, when you see this, you write down y equals mx plus b. I also want you to remember that you have to substitute for m and b. Okay, so you need to know what m is, you need to know what b is. If you don't have m, then you've got to find it in some way. Pretty easy to find when you're given 2 points. So we're going to come over here to the right, and I'm going to calculate, remember, y2 minus y1 over x2 minus x1. We're going to see this is x1 and this is y1, and my second set is x2 and y2. So y2 is going to be 2 minus y1, which is 0, divided by x2, which is -1, minus x1, which is 3. 2 subtract 0 is 2. -1 subtract 3 is -4. Simplify your fractions always to lowest terms, and a positive divided by a negative is an overall a negative. And again, 2 and 4 reduce because they both can be divided by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So now I have a slope. So my next step is writing this as y equals m, which is -1/2 x plus b. Now my next move is going to be to calculate b. I don't know what b is, so I've got to substitute for y and substitute for x so I can find b. Then you ask, okay, well fine, but what am I going to use to substitute for y and x? Either set of points. You got a 3 and a 0 you can work with here for x and y, or you have a -1 and a 2. What you cannot do, kind of like calculating slope, you can't mix and match. My advice is use 3, 0, because whenever you have an opportunity to use 0 in a problem, it just makes your calculations easier. So I'm going to say 0 is y, so there's 0 equals -1/2. My x is 3 plus b. Okay, now I've got to multiply -1/2 times 3. If you like, you can put that 3 over 1. And remember, to multiply fractions, you multiply numerator times numerator and denominator times denominator, which gives you -3 over 2 plus b. To isolate b, what I want to do is add 3/2 to both sides of this equation. The -3/2 cancels on the right, so I'm left with a b on the right only, and 0 plus 3/2 on the left, which we know is 3/2. But here's the deal, y'all. If that wasn't a 0, we would have to find a common denominator and add those together. Okay, so keep that in mind if you don't have a nice number like 0 to deal with. So our final result is we have y equals, again, put your slope back in. I'm going right back here. Your slope is -1/2 x and plus b, so plus 3/2. Alright, so we're writing the equation of a line. So where do I start? You know where, y equals mx plus b. And I'm going to plan to substitute in for m and for b. And I have to be given m and b, or either I have to calculate m and b. So this time, notice we're given a point. That's an x and a y. We have an m. Our slope is 0. So let's do that. It's going to be y equals 0x plus b. Well, look what happens here. Okay, so that 0x was going to be 0 plus b, which is b. Okay, now we can go from here. We do have a y value. It's 3. So that says 3 equals b. And we can go right to our final result. So back at the top, y equals 0x plus 3, or y equals 3. I know that looks weird, but that's what happens when you have a 0 slope. Now here's another way to think about it. Okay, and this is why I gave this problem. I want you to think about this a different way if possible. Alright, so if I plot the point -2, 3, it's right here. And I want my line to have 0 slope. Y'all remember what 0 slope means? It means that it has no incline. That's the easiest hike you could ever do, right? There's my line right there. Now what I need you to know is that no matter what x is, if you'll notice, y is 3. No matter what, y is 3. That a horizontal line is of the form y equals a number, so that gives you y equals 3. So add this to your notes. Horizontal line is always y equals a number, okay? So that would lead you to believe that a vertical line is always x equals a number, and that is true. So y equals a number is a horizontal line, x equals a number is a vertical line. A lot of people get that mixed up because the x-axis is horizontal and the y-axis is vertical. But that's the way it works. To give you a horizontal line, you want your y to be the same number every time, okay? Alright, for the last problem on this video, write the equation of a line that passes through the point 1, 7 and has an undefined slope. So again, write the equation of a line leads me to y equals mx plus b. And normally that works perfectly every time. But we have a special situation right here. We have an undefined slope. So how do you plug in undefined for an m and then go anywhere with that? There's ways to do it, but what I would rather you do is remember, what does it mean to be undefined? So if I plot the point 1, 7, which is what it's supposed to pass through. And I remember that undefined simply means I have an incline I can't hike, so I have a vertical line. Okay, I need you to know from the previous page that x equals a number is a vertical line, or another way you can think about it is x is 1. No matter what y is, x is 1. So the equation is x equals 1, and that's it. I hope that helps writing the equations of the line. The next video, we'll spend a little bit more time writing the equations of lines and also graphing straight lines.